Hi, welcome to our pre-calculus. The lecture today is double angle identities problem type 2. So what does type 2 mean here? Type 2 means from this set of identities that we have uh, practiced last time, we are going to go from right hand side to the left hand side. Previous lecture was from left to right. Now we're going from right to left. So we are kind of learning how to put the car in reverse and drive backwards. That is what we are doing here. Here are some very short examples. Cosine square of 3 pi over 5 minus sine square of 3 pi over 5. Cosine has the advantage, or if you wish, disadvantage. There are three formulations for it, three reincarnations of this formula. We need all of them. That these formulas come up in power calculations in circuit analysis, but for now we're just practicing mathematical operations. So what is this going to be? Cosine, it's the middle form of cosine square minus sine square. All we do is that this angle is going to double, so it becomes cosine of twice 3 pi over 5 boils down to 6 pi over 5. So on the template that is available to you, you figure out, well, you type cosine and there is a place for you to click on a pi and a fraction, and then you arrange this thing so that it comes out right. 2 sine of 19 degrees times cosine of 19 degrees. What is that reminding us? It matches the right hand side of this identity for sine of 2a. So 2 sine cosine is same as sine of double the angle. So here is going to be, this is equal to sine of double the angle, double of 19, and this is in degrees. So when you are entering your answer there, don't forget that from the palette there you have to pick the degree symbol. 38 by itself is not going to be clear as to what it is. Is that 38 radians or 38 something else? So it's in degrees. We have to put the degree symbol. If you don't put it, it assumes that it is in radians. So that's the convention in your software. 2 cosine square of 22 degrees minus 1. Who is that? So let's call this thing formula 1. This is 2a, 2b, maybe 2c, and this is formula 3. So what we have over there is what? Cosine square minus 1. So that is formula type 2a. Either way, it's just cosine of double of the angle. Sorry, cosine of, cosine of double the angle, double of 22 degrees. That's cosine of 44 degrees. The software is not expecting you to use a calculator to give the answer, some decimal numbers and such. No, you're just entering cosine of 44 degrees, and again, do not forget the degree symbol. Tangent, 2 is tangent over 1 minus tangent squared, formula type 3. That gives you tangent of double of the angle. So this is going to give you tangent of double of the angle. Well, what is the angle? The angle here to begin with was theta over 3. So this is good enough. 2 theta over 3. And theta, how do you enter theta? On the palette there is a theta. You just pick that on whatever angle theta is. It just copies here. This one is slight modification. You notice that that 2 is missing, and this is 2 theta here. So over here it becomes 4 theta. Let me rewrite the identity. Make sure we don't go wrong here. So we had sine of 2a is 2 sine of A, cosine of A. Now, who is our A? A is itself 2 theta. So A is 2 theta, so this becomes 4 theta. And there is a factor of 2 is missing. If you wish, you can write your identity like this. 1/2 of sine of 2A is sine of A cosine of A. So if you don't have a 2 here, then you have to compensate on that side by dividing that one by 2 as well. So all told, sine 2 theta cosine 2 theta becomes 1/2 of what now? Sine of, you want to pause here, make sure you followed, and then you come back, okay? Pause and then come back. Twice this angle, 4 theta. Okay, so that's a slightly tricky there. 1 minus 2 sine square of 3 pi over 11. That is formula 2c. Formula 2c here, 1 minus 2 sine squared. That becomes cosine of, double of the angle that you have. You clean it up. Cosine of 6 pi over 11. And it's radians, doesn't need a symbol. You pick the pi from the palette there, and then you'll be all done. So what did we do? We learned to go from right of this right hand side to the left hand side of the double angle identities. That's what we practiced today. We noticed that whatever angle here given, we have to double it on the other side. Yeah, whatever is here has to be doubled on the other side. There are a factor of 2's all over the place. We have to be careful about them. Okay, until next time, good luck and God bless.